In this lesson, we're going to talk about the qualities of a parallelogram and how you know something's a parallelogram. So the definition of a parallelogram is a quadrilateral that has two sets of parallel sides. We always say two pairs of parallel sides or two sets of parallel sides. You don't want to say all sides are parallel. That doesn't make sense. Four sides can't be parallel to each other. So you have to have two sets or two pairs of parallel sides. That's just the definition. Then we're going to get into the properties of parallelograms. One of the things we know about parallelograms is that their opposite sides are congruent. We also know that their opposite angles are congruent. So A is congruent to angle D and angle A is congruent to angle C and angle D is congruent to angle B. The consecutive angles are supplementary. So X and Y are going to have a sum of 180 degrees. And since we know that this would also be Y and this would also be X, these two are going to be supplementary. These two will be supplementary. These two, any two, sometimes they're called consecutive, sometimes they're called adjacent. Either way works. And then the last thing is that the diagonals bisect each other. So they intersect at the midpoint of each diagonal. You want to be careful with this one. This is saying E is the midpoint of AC and DB. It's important to know that AE is congruent to EC, but they're not congruent to the others. DE is congruent to EB. So they're not all four the same, but AE and EC, AE is going to be equal to EC, and DE is going to be equal to EB. Okay? So I want you to take a second, pause the video, and get all of those important details written down. In this section, we're going to use those qualities about parallelograms. So you're going to be given that this shape is a parallelogram, and you're going to be asked to solve for X and Y. So in this first picture, we're looking at the sides, and we want to ask ourselves, what do we know about the opposite sides of a parallelogram? Well, one of the things we learned was that the opposite sides are congruent. So we know that 124 is equal to 4 times 4y minus 1. So you're going to set up one equation. 124 equals 4 times 4y minus 1. And then you're going to solve that equation for y. And then the second thing you know is that 3x plus 10 is going to be equal to 43. So you're going to set up the equation 3x plus 10 is equal to 43. And you can use that to solve for x. In the second image, we're looking at the angles. So our question is, what do we know about the angles of parallelograms? Well, we know that the opposite angles are congruent. So we know that U and the 66 angle are the same. So we automatically know U is equal to 66. The other thing we know is that the consecutive angles are supplementary. So we know that 3V plus 66 they have to have a sum of 180 since they're supplementary. And you can use that equation to solve for V. Okay. In this next example, we have sides and we have angles, so we're going to have to use a couple of different things. What do we know about the opposite angles? Because right here we have opposite angles, so we know that those are going to be equal to each other. So you're going to set up an equation. 3b equals b plus 84. And you can solve that equation, find b. Remember, get all your b's to one side, your numbers to the other side. And then we were also given a set of sides. Well, since they're opposite sides, we know that they must also be congruent. So we can set up an equation. 5a minus 9 is equal to 3a plus 5. And then you're going to solve that for a, and that'll give you the a value. On the next one, we're looking at parts of the diagonals. Now we know that this is the midpoint of this diagonal right here. So since it's the midpoint, we know 27 must be equal to 3s. So 3s equals 27. And then this is also the midpoint of this diagonal. So we know that t plus 5 must be equal to 19. You can solve those. Be careful on these. You want to be sure that you're not trying to set the diagonals themselves equal to each other. You can see by looking that this blue line is not the same length as the green line. So be careful with that. Okay, another thing that you're going to be asked to do, this one says find the coordinates of the intersection of the diagonals of the parallelogram with these vertices. So they're asking us to find the intersection of the diagonals. Well, we talked about where do the diagonals meet? They meet at the midpoint of each side, or each diagonal. So when you're looking at this, you can graph it, and that will give you an idea. Or since these go in order, right? A, B, C, D, AC is one of your diagonals. So you could find the midpoint of AC by using your midpoint formula. X1 plus X2 divided by 2, comma, Y1 plus Y2 divided by 2. And you can use either A and C, or you could use B and D. You might want to do both just to test. But for A and C, our X values are -2 and +2. So we're going to add those together. Our Y values are -4 and +12. I'm going to add those together and divide by 2. So on the first one we get 0 divided by 2. Well, that would be 0. -4 plus 12 is 8. Divided by 2 is 4. So this should be the midpoint, which also makes it the intersection of those diagonals. Again, you might want to graph it so you can see what's happening, and then you'll have an idea if your answer is reasonable. Okay, on this next one, it says the vertices of A, B, C, D are given. Well, 3 of the vertices are given, A, B, and D, and you need to find the remaining one. So we're going to go ahead and plot A at 1, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Here's A. And then B is at 1, 1. This is B. D is at 2, 2. So over 2 and up 2. This is D. So C needs to go in between B and D. So it might be reasonable to try and put your C up here, but then they're not going to go in order. Remember, it's got to go A to B, and then it's got to go B to C, and from C back to D, and then D to A. So this one can't be it. One of the things we can look at is how did we get from A to B, and we can do the same thing to get from D to C. So it's a length of 4, and it's just vertically straight down, so we're going to do a length of 4. And it's going to be right down here, right off of my graph. It looks like at +2, comma, -2. And we're just judging by our graph where that would go. And then this is what our parallelogram is going to look like. Now, the last thing that we're going to talk about here is how to decide if a statement is true, always, sometimes, or never for parallelograms. So this can be one of those tricky things for people. So I want to give you a couple of tips. One is, since you're talking about parallelograms, start by drawing a basic parallelogram, one that's longer than it is tall. And then draw your special parallelograms, a rectangle, a rhombus, and a square. And then you're going to use these drawings to test the statement that you're given. Okay, so let's look at an example. Oops. So the diagonals of a parallelogram are congruent. Always, sometimes, or never. So I'm going to start with a regular parallelogram. And when I look at that orange diagonal, that one, versus this one, that's not true. The diagonals are not congruent. But when I look at this special situation, when I look at a rectangle, they are congruent. What about for a rhombus? On a rhombus, they're not congruent. On a square, they are congruent. So for this one, it looks like sometimes is definitely going to be our answer. The diagonals of a parallelogram are sometimes congruent, and that only happens if it's a rectangle or a square. All right, that's all. Your homework is worksheet 7.2, practice 1 through 11. Notice I'm taking off the proof, which is number 12. Most of you, I gave you this worksheet right before you left. If you didn't get a copy of it, you can print it off of on campus. There, it's part of the assignment. All right, good luck. Let me know if you need help.